Welcome to this exercise where I'm going to talk about how to solve root equations. A root equation is an equation like this where x stands below a root sign. So something like this which we should solve for x. If we want to approach an equation like this, makes sense to first isolate one of the root expressions. So here we do not actually have to do something. We already have the square root of 2 plus x on the right hand side. Well, if it's a square root, it's more or less like a radicand of 2, which should be written over the root sign. That's important because to get rid of the square root, we're going to square both sides of the equation. If there were a radicand of, let's say, 5, we would have to take both sides of the equation to the power of 5. Well, in this case, squaring this, on the right side gets rid of the root sign. On the left side, I have two expressions connected with a plus. So what I have to do here is use the first binomial form, which results in this. So it's square root of x squared. Well, square root squared gives x itself. And then 2 times this times that. So 2 times square root of x times 1 gives 2 times square root x plus 1 squared is 1. So that's the results here. Then I can bring everything but the root expression on one side of the equation, or in other words, I'm going to again isolate the root expression by bringing x and 1 on the right side, simplifying to this version. I can then divide by 2 to really have only the root expression as such, with square root of x equal to 0.5. And finally, to get rid of this root expression as well, I'm going to square the results once more, giving me a final result of 0.25. Well, so far so good, but I also have to check whether this result is a feasible result. Meaning, I'm only allowed to insert into square roots positive values or 0. So I have to check if I insert this value, there's some problems occurring. Well, in this case, if I insert this here, that's obviously positive, so no problem here. If I insert this here, I have 2 plus 0.25, so again, it's positive, so no problems here either. So this is not only a solution to this, it's also a feasible solution to this equation. So we solved our exercise and are at the end of this session. So I say goodbye and see you again.